In class, we will be discussing how to organize and graph both qualitative and quantitative data. In the previous video, I mentioned how if data is quantitative, if it's numerical in nature, there's further analysis that we can do on a data set that is numerical. And one of those things that we can do is talk about where the data tends to center around. So we're going to discuss these things called measures of central tendency. Okay. This comes from section 13.4 in your book. Okay. Now, measures of central tendency are often referred to as an average. Average is just a generic term that means a number that is representative of a data set. Now, there are a lot of different averages out there. Okay. There is mean, median, mode, mid-range. We're going to talk about 3 of these averages, which are specifically measures of central tendency. Each one of these 3 things we're going to discuss are calculated differently, so it's no surprise that often they lead to a different value. Okay? The first one we're going to talk about is the mode, and many of you are probably familiar with this from an elementary statistics unit that you have done before. But if you recall, the mode is simply the data value that occurs with the highest frequency. What does that mean? It simply means that it's the data value that turns up the most. So the data value that occurs with the highest frequency. We're going to look at a couple of data sets, small data sets. The first one is 2, 4, 4, 6, 8. Looking at this data set, we see that 4 turns up with a higher frequency than any of the other values, so we would say that the mode is 4. However, if we look at another data set, in this particular case, we see 2 data values that occur with a higher frequency than the other data values. So in this particular case, we actually have 2 modes, 2 and 4. When a data set has 2 modes, we call it bimodal. Bi is the prefix meaning 2, such as in bicycle. It is also quite possible to have a data set that has no mode. If every data value occurs with an equally high frequency, then that particular data set has no mode. Okay? So mode is one of the measures of central tendency. Another measure of central tendency that we'll talk about is the mean. And this is the one that when people hear average, this is the one that they think of. This is formally known as the arithmetic average. And I'm sure every single one of you know how to do this, because if you've ever calculated your grade in a class, you've done this. The way to find the arithmetic average is to add up all the data values and divide by the number of pieces of data. In just a few minutes, you'll get an opportunity to do an example. I don't really think we need to do an example together. However, what I do want to share with you is the notation. X bar, it's really just 1 bar over the X. So let me see if I can draw this a little better for you. X bar is the notation we use to indicate the mean. The formal formula, if you will, this funny letter that I just drew right here is the Greek capital letter sigma, and in math it stands for the summation. So what we're doing is summing all the x's. X is the data values. So you're finding the summation, or you're adding up all the data values, and then we put it over n. Writing it as a fraction means we're going to divide, and n is the number of pieces of data. So this is the formal way of saying add up all the data values and divide by n. What I really want you to remember is that X bar is the symbol for the mean, because what we're going to see in class when I show you how to use your calculators is that this is how your calculator indicates the mean. So I want you to be familiar with that symbol. Okay, we have one more measure of central tendency to talk about, and that is the median. The median is the exact middle piece of data in a data set. So it's the exact middle piece of data. Now the thing is, you have to be careful, because to identify the median, you have to have the data in ascending order. So the data must be organized, so it must be in ascending order. That means from lowest values to highest values. Okay? So let's take a look at an example, and we'll find the median. Okay. Now, I've already organized the list for you, so you can kind of eyeball a list of data and sort of feel out where the middle is. In this case, because it's a small list, it's pretty easy. If you look at the data value of 3, we have the exact same amount of data below as we do above that data value. So half the data is below 3, half the data is above 3. What that tells us then that for this data set, the median is 3. Let's consider another data set. Let's consider the data set 3, 4, 5, 6, 7, 8. Now, we can kind of start to feel where the middle is. Maybe you're thinking it's 5. Well, the problem with 5 is that there are only 2 pieces of data below and 3 pieces of data above. So there is not an equal amount of data below 5 as there is above 5. That means 5 cannot be the median. So maybe you're thinking you'll fix that by scooting over to 6. But now there are 3 pieces of data below 6 and only 2 above. Sort of in the same pickle where we don't have an equal amount of data above and below 6. In a case like this, sometimes it happens where the the median is not actually one of the data values. The median will actually live right between these 2 middle pieces of data. So at exactly halfway between 5 and 6, we will get our median. Because notice, between 5 and 6, if we land there, we have 3 pieces of data below, 3 pieces of data above. So exactly half the data is below, half is above. Now in some cases such as this, it's very easy to identify what halfway is. I mean, what's halfway between 5 and 6? Well, 5.5. However, sometimes there's a larger spread between those 2 data values, and it's not as obvious what halfway is. So if you ever get into a pickle and you're struggling to find that exact halfway point and you don't want to hunt and peck all day, you can always add up those 2 middle data values and divide by 2. Check it out. 5 plus 6 is 11, and when we divide that by 2, we get our 5.5. Okay? If it's obvious, if you can pinpoint halfway, then just do it. But if it's not as obvious, you have a strategy now for identifying halfway. Okay, so what I would like you to do now is find the mean, median, and mode for the following data set. Okay. The data set is as follows: 98, 71, 32, 70, 71, 62. Pause the video for a moment, please, and find the mean, median, mode for this data set. Then resume the video to see the answers. Okay, welcome back. I assume to find the mean, you just went ahead and used your calculators, added up all these data values, and came up with the mean of 67.3. The mode is not hard to find because this is a small data set. We can scan this small list and see that the mode is 71. That is the data value that occurs with the highest frequency. The median, however, if you happen to say that the median was 53, I believe, you were making the common mistake, or I suppose it would be 51. You were making the common mistake of forgetting to organize your list. When we look at this data set, I know that you see 6 data values, and you know that the median is going to be halfway between these 2 middle ones. but we can't just go halfway between 32 and 70. We have to remember to make sure that we put our list in ascending order. So I'm just going to quickly rewrite this list, and when I do, now I can accurately identify the median. True that at 70 we do not have an equal amount of data as we do above. And likewise, if I jumped over to 71, I'd be in the same boat. So I think we all realize that the median is going to be in between the two middle data values, because then we have an equal amount of data above and below that point. Well, halfway between 70 and 71 we know is 70.5. So the median of this data set is 70.5. Please make sure you're comfortable finding these three measures of central tendency. In class, we will go over how to use your calculator to find these.